Good day everyone, my name is Oswagu Samson Ikedinachi. Chemistry Hangout is the best channel I can ever recommend for any student who is wanting to write WAEC, NECO or JAM. In fact, it is the best channel. It really is the best channel because it really helped me a lot. It helped me a lot in my WAEC and my NECO. I wasn't good in chemistry at all, but when I joined this channel and I listened to some kind of teachings over the channel, I really loved it, and I can say it really helped me a lot. It really did. It helped me a lot. So for you who is wanting to write WAEC, JAMB or NECO, I really recommend you to join this channel. And also don't forget to subscribe. Just click on the bell button there to give you notification and subscribe.
Hello, you are welcome to Chemistry Hangout. It's been a while on this channel. I want to say welcome. If you are just watching this YouTube for the very first time, I'm welcoming you chemically. And if you have been a subscriber here, you should be able to attest that this channel has really been helpful in exams and really putting clarifications to a whole lot of things. So I welcome you again to another chemistry section on Chemistry Hangout. And before I do anything today, let me quickly congratulate my WAEC students all over Nigeria and other countries. My inbox is filled of excellent results, and I must confess that I'm excited and I'm very, very happy, to be standing here today to say well done for those excellent results. Well done for actually coming to our channel. Well done for sharing the channel. Well done. Keep it going. Don't relent. Those results were wonderful. They were wonderful results. A1 in chemistry, a whole lot of A1s. And I look fulfilling because I felt it's a privilege for me to be able to help so many students all over the world. So congratulations to people that wrote WAEC, and the result was very, very wonderful. I'm excited and happy, and I'm assuring us that Chemistry Hangout will keep giving us nothing but the best. So what you just do for us is, if you are watching this YouTube for the very first time, just kindly subscribe. You can share the videos, tell a lot of people to subscribe to the channel, because we are actually still preparing something very, very huge for you guys. So I'm happy to be here again. Congratulations to WAEC students, and I welcome you again to another section. Now, very quickly, for the JUPEP student, I've not been creating content for them, but a whole lot of them have reached out to me. So what I will do, maybe other subsequent videos, I will take the JUPEP question for this year and try to solve it, make clarifications to it, so that it will serve as reference for other students that will be taking JUPEP next year. Some of them reach out to me, and I'm sure I'm able to help in my own little way. So I'm going to be ditching out content for JUPEP students, IGMB students. We're going to be doing that. But just what we need you to do for us, keep praying for us, keep sharing the video, keep subscribing, and we know we are going to grow together. So welcome again. Today, what I will quickly do is, for people that are preparing for GC, a lot of them has reached out to me again to actually just do something for them that can serve as a morale booster or encouragement for them, what to study and what they actually need to do to prepare for this oncoming GC that they are going to write. So today I am here to actually give my own consent of what the question is going to be like. I have always said this, and I'll continue to say this, that what we do on this channel, I'm not saying this is what will come out, but if you are able to follow dutifully and carefully of what is being taught here, then you should not have any problem in your exams. Our subscriber can actually bear me witness. So please just follow me dutifully this morning while I do justice to some of the GC questions. I will solve one. I have two questions for us. This is one, this is another one. So I will solve this and explain how this is going to look like, so that you can do that yourself, and you just put the answer in the comment box section for me to see if you are correct or you are not. So welcome quickly. Now let me just give a brief intro of how GC question look like. You know, GCE is just like WAEC, okay? GCE2 is the same body that actually controls it. But the difference between chemistry WAEC questions and chemistry GCE questions is because GCE has saved you a whole lot of stress because it's an alternative to practical. What do we mean by alternative to practical? Means the values you need to an extent, the titration, either the reduced titration or the acid-base titration has been carried out and they have given you the value. Directly or indirectly, they have given you the value. So in WAEC, instead of you to titrate, now in GCE you are not titrating. It's either they give you some mathematical way to actually go about the calculation or they give you directly the title value in the question. So it's very easy. If you are writing GCE, if WAEC student that does the practical, that did the practical, could be able to get A1 after going through the rigors of doing the practical, then if you are writing GCE, you should not have anything less than A1 because you are not doing the practical. A whole lot of things has been done for you. Your own is just the calculation part. So just pay attention to me this morning while I take you through.
Good day everyone, I am Omotosho Abibola Messi, proudly a 100 level biochem student from Kwara State College of Education, Oro. Saying the biggest thank you will not be enough to express my fondness for chemistry hangouts. It has really helped me for a whole lot of revelation in certain topics in chemistry. It helped me in understanding basic, intermediate and advanced topics in chemistry all through my WAEC and JAM. So do you have problem understanding certain topics in chemistry? Do you want all phobias for chemistry to fly away? Then the best channel is Chemistry Hangout. So subscribe to this channel and you say bye-bye to chemophobia.
So let's look at this. That's the first likely questions I am actually predicting that question might actually look like this. The question says A is a dilute tetraoxosulfate 6 acid. B contains 1.50 gram of sodium hydroxide per 250 centimeter cube of solution. 25.0 of B require this 15.50 centimeter cube of A for complete neutralization. Now look at this. From the question, two values have been given to you. Very, very important. That you are supposed to do the practical yourself because you are supposed to do the practical to get the average title value, which we know as the title value. Okay. So, but now reading the question, if you look at this, A is a dilute tetraoxosulfate 6 acid. B contains 1.5 gram of sodium hydroxide. So they are giving us the mass of sodium hydroxide in 250 centimeter cube of the solution. Now coming to the next line, they say 25.0 centimeter cube of B. What do you mean by that? Meaning the volume of base, because your B most times is always your base, and in acid-base titration, you pipette it. So which means the volume of pipettes they used is 25.0 centimeter cube. Very, very important. Of B required 15.50 centimeter cube of A for complete neutralization. Meaning for the reaction to be neutralized, the title value or the average title value that is being used is 15.50 centimeter cube. Can you see? Very simple. So unlike WAEC, you're supposed to get all this yourself, state this yourself. And that's why if you're writing GC, please be careful. Sometimes this place might not be 25, it might be 20. They might give you 20, they might give you 25. Read the question very well to know what have they given you and what are you actually asked to calculate. So they are giving me the volume of base, which is 25.0 centimeter cube of B. That's the volume of base. Required 15.50 centimeter cube of A. That's what? That's the volume now of acid. Can you see that? So volume of acid is this, volume of base is this. Then with that, they said write a balanced equation for the reaction. So what is the reaction? A dilute tetraoxosulfate 6 acid. So that's where we are starting from. So we say equation. We say equation of reaction. So an equation of reaction, the reaction is between dilute tetraoxosulfate 6 acid. You should note that that's H2SO4 in the aqueous form because those solutions will be in their liquid form, plus sodium hydroxide. That is sodium hydroxide written like this. I hope you are following in the aqueous form. To give us very easy. How do you get that? Don't forget, you should be familiar with that. Na plus, that's the valency. I'm just trying to, give you a way to write equation. Na, you have something like this. Na, if you dissociate, you have OH minus. Can you see? If you dissociate, that's this. For this H2SO4, you have 2 hydrogen ion plus SO4 2 minus. Can you see that now? So if this dissociates, it gives this. If this dissociates, it gives this. Does that make any sense? So what happens? Your positive sign attracts negative sign. Your positive side attract negative sign. So I'm going to have something like this. This one attracting each other and this one attracting each other. Can you see that now? So and when they are actually attracting themselves, they exchange their valence. So this becomes Na2SO4. So the product of Na2SO4. Can you see that now? Na2SO4. Then we have H this plus this. That gives us H2O. Can you see that? Plus H2O. Can you see that now? So the next thing we do is, let's check if the equation is balanced. So we have 2 hydrogen here. Very important, you have 2 hydrogen here. Correct? You have 1 sulfur, you have 1 sulfur, okay? You have 4 hydrogen plus 1, 5. You have 4 hydrogen plus 1, 5. Okay? We have sodium, 1. We have sodium here, 2. So what do? We balance, we put 2 here. Immediately you put 2 here, please start from the beginning to check because some things might have changed, okay? So we have how many hydrogen now? We have 2 here, we have 2 now. Before we have 3 here, we have 2, it's not even balanced. But now we have 2 plus another 2, making 4. But here we have 2, so I can still put my 2 here. This is H2O. So let's start again. You have to be very, very careful. Take your time, please. Take your time to be sure you are doing the right thing. So this hydrogen, that's 2 plus another 2, making 4. Hydrogen here 4, balance. Sulfur is 1, sulfur 1, balance. Oxygen is 4 plus 2, that's 6. Oxygen is 4 plus 2, that's 6, balance. Can you see that now? Then we have sodium 2, sodium 2. The equation is balanced now. Very important. Because there is mark for this, that's why they said write the balance equation for the reaction. So that's the balance equation for the reaction. That's A. Okay. Now the next question. Calculate the concentration of solution B in mole per dm cube. If you have been following the videos, if you are writing GC, please, I persuade you to check other practical videos because they are just the same. The only difference is that you are not doing that practical yourself, which makes this work to be very, very easy. So I will do this, I will explain how this is done, you do it yourself, and you check other titration questions on the channel for you to be confident before that day. So they say calculate the concentration of solution B in mole per dm cube. So let's go to solution B. They say B contains 1.5 gram. Let me start that now. B. That's number figure 1. Very, very important. The numbering. So they said B contains 1.50 gram in 250 centimeter cube of solution. Please pay attention to that. Now, if they ask us to calculate the concentration of B in mole per dm cube, I have said that the first formula that will come to your mind is your mole. Let me write it here. Is your mole equals mass over molar mass. You check this formula. Can it solve the question? Let's see. I'm calculating concentration of solution B in mole per dm cube. So this is mole, okay? Now, do I have mass in the question? Let's go to B. I have mass in the question, but the mass is in 250. Please, very, very important. If what I have here is 1.50 gram per dm cube, it means that I have 1.50 gram in 1,000 because 1 dm cube is 1,000 centimeter cube. So you can use the value directly. But now they are telling you that it is in 250. That's not the standard measurement. The standard measurement is 1 dm cube. So what do? I need to convert to 1 dm cube. So for now, we can convert this mass to 1 dm cube because they gave us a 250, meaning we can get the mass. That's correct. Now the molar mass, can I get the molar mass? Let's see. They are giving us sodium hydroxide, which is NaOH. And if you look at the question, they have given us those atomic masses. Sodium atomic mass is 23, it is here. Oxygen is 16, it is here. So hydrogen is 1, it is here. So we can go with this very particular formula. I hope you are getting that now. So the first thing I do is to convert this to 1000, because 1.50 gram in 250 is not supposed to be in 250. So maybe it is in 500 or 250 or 750, you need to convert to 1000. I hope that is clear. So from here now, I can say 1.50 gram is in 250 centimeter cube. So in 1000 centimeter cube, what is going to be the mass? So I cross multiply. So from here I'll be x equals 1.50 times 1000 over 250. So our mass now, we can use our calculator now. Please, you have to be very careful. So 1.50 times 1000 divide 250. I'm adding 6 grams. So it will be 6 grams now per dm. Can you see that now? So meaning 1.50 grams in 250, that's the first one. So I've converted this one out to 1000, so it will just be 6 grams. Do you understand that now? So the mass now is 6 grams. So I can use this formula now, which is this. The concentration now, concentration in mole per dm cube will be equal to mole is equal to mass over molar mass. Okay? Please, all your calculations should be in your booklet. We are getting our mass, which is this. We need to get our molar mass. So what is our molar mass? Our molar mass now will be equal to sodium hydroxide. Sodium is, that's NaOH. So that will be 23. They are giving us plus 16. As oxygen, it is being given plus 1. So we have 23. That's 39 plus 1. That's 40. So I have 40 grams per mole. Can you see that? Those units are very, very important. Please take your time. Those units are very, very important. So from there, we can now apply this, which is mole equals, what is my mass? That's 6 grams per dm cube over, what is my molar mass? That's 40 grams per mole. Okay? Gram, we cancel gram. So my mole is now going to be 6 divided 40. 6 divided 40. And that will be 0.15. 0.15 mole per dm. I hope that is clear. This is very clear. So, number one, that's the reason why I said for GC students it's a bit easier for you, because most of those things are given already. So, from the next one says concentration of A in mole per dm cube. That's the second question. Concentration of A in mole per dm cube. The first thing I will still do is, can this formula solve it? Mole is equal to mass over molar mass. Let's go to A. You can see they didn't give you the mass of A. They didn't give you the mass. Okay? Even if you can calculate the molar mass of A, because you know it is H2SO4, they are not giving you the mole, because the question is if you calculate the concentration in mole and they didn't give you mass. So you cannot calculate two unknown at the same time, because you don't have the mass of A, you don't have the mole of A. That's to calculate the mole of A, but you don't even have the mass of A for the question. So what do? You use our titration formula. You should be familiar with it. You can check other titration questions on the channel. So we have C A V A over C B V B equals N A over N B. I hope you are following. So what is our Ca? That's the concentration of acid. That's the concentration of acid. You know the question is concentration of solution A. That's Ca. Concentration of acid. That's what we are looking for. I hope that's clear. Our Va, volume of acid. Go back to the question. That's what I call the what? The titer value. Because 15.5 centimeter cube of A. That's the volume of A. Even looking at the units, you know that's the volume of A. So that's 15.50 centimeter cube. I hope you are following. Your Cb, concentration of base, that's what we are plotting here. That's 0.15 mole per dm cube. That's Cb. Vb, go to the question. All these things are there. Look at it, 25.0 centimeter cube of B. Centimeter cube, that's the volume of B. So my Vb is 25.0 centimeter cube. I hope you are following. Why? Our Na, that's number of moles of acid. We go back to the equation of reaction. That's why balancing of this equation is very, very important. Very, very important. Please, you have to be careful about it. So, number of moles of acid. Look at this acid. You have 1 mole of H2SO4. 1 mole, because you don't have any coefficient. So that's 1. So that's 1. Then our NB, number of moles of base, you can see that's 2. So we can slot in all this in this place now. So our Ca times our Va, that's 15.50 over Cb, that's 0.15, that's 0.15 times Vb, that's 25, I hope you are following, equals number of moles of acid, that's 1, over number of moles of base, that's 2. So we can cross multiply. So if we cross multiply now, making Ca the subject, we're going to have Ca to be equal to 0.15 times 25 times 1 over, you know, we are making this the subject of formula. So it will be this multiplied by this over this. So we are going to have 5.50 times 2. I hope you are following. So Ca. Please, some of you, let me quickly correct that. You want to actually use your calculator, you now punch 0.15 times 25 times 1, divide 15.50 times 2. From experience, it will give you the wrong answer. So do it one after the other. So the first thing I'll do is 0.15 times 25 times 1. That will give us 3.75. So I write 3.75 over 15.50 times 2. That will give us 81. You can see. So now you can now do your division. 3.75 divide 31. You can see that's 3 significant figures, 0.12096. That's what I have here. 0.12096. So I can say 0.121. Okay, mole that's it. That's it. So the next question says 3. Number of hydrogen ion in 1.0 dm cube of solution A. Number of hydrogen ion. Can you see that? Number of hydrogen ion. And we know for that very particular solution to produce hydrogen ion, it means it is an acid. So we are working on the acid now. So number of hydrogen ion in 1.0 dm cube of solution A. So from there, I'll say the acid is what? H2SO4. I hope we are. So if this dissociates, for it to be able to give us hydrogen ion, it has to dissociate. So if it dissociates, it's going to give us what? H plus SO4 2 minus. You have 2 hydrogen ions. I can balance this. Can you see that now? So if it dissociates, it will give us this. Can we see? Which means 1 mole of H2SO4 will give 2 hydrogen ion. 1 mole of this will give this. This stoichiometry, I'm still, in my subsequent videos, I'm still going to make a topic on that on its own. Because a whole lot of students have been asking of that. So I will do stoichiometry, because this is a stoichiometry because you must pay attention, you should understand it. So the first thing is, the answer to do for number of hydrogen ion, okay? I am now writing this dissociation reaction of H2SO4, which means H2SO4 will be this and this. Let's say, for example, it is HCl. The dissociation reaction will be H plus Cl minus. Can you see that? So, but this is not what the answer to do. We are working on H2SO4. Okay, so from here now, 1 mole. Now look at it. So I can say 1 mole of H2SO4 from this equation gave us 2 moles of hydrogen ion. Gave us 2 moles of hydrogen ion. From this, 1 mole of this gave 2 mole of this. Okay, now I'll now go back to the question. What is the concentration of acid that we got? 0.121. Can you see that now? So if 1 mole of H2SO4 gave 2 mole of hydrogen ion, the 0.121 we give what? We give X. Because from the equation, 1 mole of this gave 2 moles of hydrogen ion. So 0.121, which is the concentration of acid here, we give X. So from here, our X is going to be 0.121 times 2. So our x here is going to be 0.121 times 2. So it's going to be 0.242. 0.242. Can you see? 1 mole of this gave 2 moles of hydrogen alone. Is 0.121. We give what? We give x. Can you see that now? If 1 mole of this gives this, I hope you are following, is 0.121 of this, we give how many? So give 0.242 moles of what? Of hydrogen alone. I hope this is clear. 1 mole of this gave this. So from the concentration of acid here, which is 0.12, to give x of this. So if I cross multiply x times 1, give me x. Okay? 0.121 times this will give me 0.242 moles of hydrogen alone. But remember that they gave us Avogadro's constant here. 1 mole of hydrogen alone is going to be 6.02 times 10 raised to the power 23, because the Avogadro's constant here is given already. Don't forget, the question is we should look for number of hydrogen alone, not moles of hydrogen alone. So we are just coming through moles to get the number of hydrogen alone. So from there, I can now say 1 mole of hydrogen alone by Avogadro's constant is going to give us 6.02 times 10 raised to the power 23. Can you see that? 1 mole of hydrogen alone is going to give us 1 mole of hydrogen alone is going to give us 6.02 times 10 raised to the power 23. So is 0.242 moles we give x. These are stoichiometric constants. So 1 mole of hydrogen alone will give this 6.02 times 10 raised to the power 23 aeons. That's Avogadro's constant. 1 mole of hydrogen alone is going to give 6.02 times 10 raised to the power 23 aeons. It can be aeons, can be protons, depends on the particle that you are giving. But now, what they want us to calculate is aeon. So 1 mole of hydrogen alone will give 6.02 times 10 raised to the power 23 aeons. So it's 0.242 of this we now give x. So here now the x times 1, that gives us x equals, then it will be 0.242 times 6.02 times 10 raised to the power 23. So I can now use my calculator to get the number of hydrogen alone. So from there, just multiply this and this. If you are not that good math, just multiply this and this, then write times 10 raised to the power 23. So it will be 0.242 times 0.242 times 6.02. And that will give us 1.45. That will give us 1.45. Let me approximate to 3 decimal places. That 14568. That's what I have here. So I can say 1457 times 10 raised to the power 23. So that is that. I hope this is clear. Take your time to actually understand this. Take your time to understand this. Take your time to understand this. So all these questions, these are the way it goes. Don't forget, if you're writing GC, most times when I give you the volume of acid, give you the volume of acid, the volume of base, the question can come like this. So take your time to actually go over it. But now, I'm leaving this for you. Look at this now. You can practice this. I'll just explain 1 or 2 things here. Look at this. They didn't give you your volume of acid. They drew the table for you to complete it. So if you are not familiar with how the titration table is actually like, you might be making mistakes. They might omit some things here. So what do you do here? Ideally, what you're supposed to do for every table that looks like this, let me rule this. For every table that looks like this, what happens is the way we get the volume of acid used here is to subtract this from this. Okay? Subtract this from this. Sometimes they will give you this value. I hope that is clear. So if you are giving a table like this, what do? You always subtract the initial readings from the final reading. So if you subtract this, it's going to give you 25.20. Can you see that? If you subtract this, it's going to give you 22.50, if I'm not mistaken. 23.70 plus 1.20. 23.70 plus 1 minus, sorry, not plus. 23.70 1.70 minus 1.20. That gives us 22.50, right? 22.50. So you are subtracting this from this to get this. You are subtracting this from this to get this. You are subtracting this from this to get this. So that will be 45.10 minus 22.50. That's giving us 22.60. Please, for you to be sure, you can use your calculator. They're not going to penalize you for that. That's why you have a calculator. So now look at this now. I have gotten this. Sometimes they might give you this and this. Can you see that? They might give you this and this, meaning you are going to subtract this from this to get this. If they give you this and this, you subtract this from this to get this. I hope that is clear. Sometimes they will omit it, but just know that the way you get it is you subtract the initial from the final, initial from final to get this, and that is that. So look at the question, and now say copy and complete the table. So I've completed the table like that. You have gotten the mark for that. So the question will now be, write a balanced equation for the reaction. You can do that yourself and put the answer in the comment box. What is the reaction? HCl and what? Potassium hydroxide. So you can do that on your own. Just use that as practice question. They now said, BI, what is the average? Calculate the average titer. They are supposed to give you the titer because here they gave you the titer already. 15.50. They gave you the titer here already. But here, after you have completed the table, they now say you should get the titer value yourself. How do you get the titer value yourself? If you look at this 25.20, that's the rough. 22.50, that's first. 22.60. Now check the rough. You will see the value of the rough is far from the first and second. I hope that is clear. Look at it. It's far. Even most times, most students don't even use the rough because most times, from experience, the value is always a bit wide from other values because that's the first titration. So look at this one. I have 25.20, 22.50. These ones are closer, so you are not using this. So what you do here is you want to calculate your average titer. It should now be my average titer will be 22.50 plus 22.60 over 2. Can you see? Because you are picking these two, you picked only these two. So it will be this plus this divided by 2. Just like you are looking for me. You are not going to use this because it's far from them. So when you do this, you are going to get the average titer, okay? And from there, you calculate concentration of HCl in mole per dm cube. You should be able to do that if you understand what I've done. Then from here, again, they say you calculate number of hydrogen in 1.0 dm cube of solution. So and that I have even said that before because that's HCl. So if you dissociate it to the H plus Cl minus. So this one is 1. You should be able to do this one too. But if you are given a table like this, that's how to go about it. No, you are subtracting this from this to get this. So if you are not giving this, subtract this from this to get this. Okay? If you are not giving this, let's say for example, they didn't give you the final readings, they omitted all this one. What do? You add this plus this to get this. Can you see that? So but just know that for you to get volume of acid, you subtract initial from final. So when you know you subtract initial from final, anyone that they omit, you should know how to go about it, and that is that. So I want to see the answers you have gotten in the comment box section, and you can go over this over and over again to be able to understand what I've done. And after this, you can also check other titration questions on the channel. Check on the channel. You have a lot of titration questions. We have 2021, we have for NECO, we have for WAEC. Last year we have for NECO, we have for WAEC. So that you can know how the only thing is that very practical, we did the practical. That question we did the practical, but this one you are not doing the practical. Just get your value. It's either they are giving you the value like this in the question, or they do something like this for you to just do some tasks and get your average value. So I wish you all the best. Please go over what is being taught on this channel over and over again. And if you are just new to this channel, if you are watching this channel for the very first time, just subscribe to the channel. You can share the video, comment, like, and we are assuring you that we will continue to give you the best. Congratulations to my WAEC students once again. I love you guys. Okay, don't relent, keep reading, keep studying, keep meditating. I hope that is clear. So for all other students taking exams, I wish you success in your exams. Thank you and God bless you.